In this section, we will explore the Hadoop distributed file system and the ways of interacting with it. Now, if you are thinking about how would you store data that is used for MapReduce, the first requirement that we have is that the data needs to reside on multiple machines. The second requirement is that we should be able to store any type of data. So the data does not need to neatly fit into tables like in relational databases, but it can be unformatted data, it can be text, it can be images. So we don't have any particular requirement on the type of data that we are storing. And here we have one problem. The first problem is that as we are running on a cluster with many machines, there is quite a bit of likelihood that at some point one of these machines is going to die. And if a machine dies, we don't want to lose the data. So one of the critical parts of Hadoop solution is how do we store the data on multiple machines without encountering loss of data if something dies? The idea that we have is to create a distributed, reliable storage. The question is, how would we do that? The solution for that is the Hadoop distributed file system, and we will see now how it works. The first thing that we do is we are going to take a large file and we are going to break it into blocks. These blocks will be stored on multiple machines. We call them nodes. So each of these machines is going to get a subset of data. And you can see here, node 1 is going to have some fragments of this data, node 2 is going to have something else, and so on. Here on the left, you see the master node. A master node has a special purpose in the Hadoop cluster, and it contains the part which is called the name node. A name node has one important piece of information, and that is it knows on which machines are which blocks residing. So it is almost like a table of contents. The next thing that we have with our Hadoop distributed file system is the replication. In order to achieve a fault-tolerant solution, a piece of data would need to be stored on multiple machines. And here we have in this illustration our fragment of data number 1 is stored 3 times. And in fact, this is the default replication of data in Hadoop cluster. So every piece of data is stored 3 times on different machines. One of the things that you need to think about is that we are actually using more space than it's really necessary for every individual piece of data. But we don't worry about that. The disk is cheap, and what is important is that we have the fault-tolerant solution that can survive a death of a machine. Now, if you think about some other solutions that we have in this space, for example, RAID drives will also store data in redundant fashion. When we are storing data on the Hadoop cluster, typically we store the data on plain, ordinary drives, so without using any RAID mechanism. Looking into the HDFS, we can say that the data is first split into blocks, and then the data is distributed across the machines in the cluster. And by default, each of these blocks is replicated 3 times. One of the interesting things that we have is that the machines that we have for our clusters are fairly cheap machines, and they tend to be relatively unreliable. They are not using the most expensive and the most sophisticated hardware. So we expect that these machines are going to die. Our HDFS provides us with a reliable solution where we don't lose the data. HDFS, in its realization, resides on top of native file systems. And normally, these machines are running Linux, so HDFS resides on top of that. We have seen in previous illustrations that we have some blocks, and that these blocks are typically going to be relatively large, 64 to 128 megabytes. And all of these ideas that we have in HDFS are following the ideas that were originally created for the Google file system, which remains as a proprietary implementation. So now when we are thinking about how should we apply HDFS, should we better work with many small files or should we better work with fewer files that are rather large? The sweet spot for Hadoop is to use a smaller number of large files. And the typical size of these files is going to be over 100 megabytes. Now, when we are thinking about our processing, and you may remember when we explored MapReduce algorithm, we were reading the data from beginning to the end. And this is something that would be important for HDFS. You don't have the random access to piece of data in HDFS. So you normally read your data from the beginning to the end. And why is that good? This is good because it minimizes the cost of seek. And we don't do updates on such files. If we need to write something new, we would put that typically in a new file. So you need to remember, when you are dealing with Hadoop and HDFS, there is no random access. We will see later some solutions that reside on top of HDFS that will allow us to do some changes. And that would be the HBase, which is the database that runs on top of Hadoop. We said that we have fault tolerance, and for that we have a replication. The default factor is 3, but you could also go higher in some situations.